Have you ever heard of planets orbiting black holes? It might sound like something straight out of a science fiction novel or a blockbuster movie, but this fascinating concept is actually being explored by scientists today. Imagine a world where the night sky is dominated not by a star, but by the eerie, dark presence of a black hole. It sounds like something out of science fiction, but scientists believe it might be possible. These researchers are delving into the mysteries of the universe, pushing the boundaries of what we know about planetary formation and the environments in which planets can exist. These hypothetical planets are called Blanets. The term planet is a combination of black hole and planet, and it represents a new frontier in our understanding of the cosmos. Planets are theorized to form in the dense, energetic regions surrounding black holes. They are like regular planets, but instead of orbiting a star, they orbit a black hole. This unique orbital relationship presents a host of intriguing questions and challenges for scientists. How do these planets form? What kind of conditions do they experience? Could they potentially harbor life? Black holes are regions in space where gravity is incredibly strong. They are formed when massive stars collapse under their own gravity, creating a point in space with a gravitational pull so intense that nothing can escape it. Nothing, not even light, can escape their pull. This phenomenon, known as the event horizon, marks the boundary beyond which nothing can return. The immense gravitational forces at play make black holes some of the most extreme and fascinating objects in the universe. So how could a planet possibly exist so close to such a powerful force? The idea seems almost paradoxical, yet the universe is full of surprises. Scientists propose that planets could form in the accretion disks of black holes, where the gravitational forces are balanced in such a way that planetary formation might be possible. The answer lies in a special region around black holes called an accretion disk. This disk is composed of gas, dust, and other material that orbits the black hole, gradually spiraling inward. The intense gravitational and frictional forces within the accretion disk can lead to the formation of planets, much like how planets form around stars. It shows us that planets might form in the most unexpected places, even around objects as extreme as black holes. The discovery of planets would not only expand our knowledge of planetary formation, but also deepen our appreciation for the incredible diversity and complexity of the cosmos. The universe is a vast and mysterious place, and with each new discovery, we uncover more of its secrets. Imagine a giant swirling disk of gas, dust, and debris. That's an accretion disk. They form around black holes as these cosmic monsters pull in matter from their surroundings. Accretion disks are like giant construction sites for planets. They contain all the raw materials needed to build a planet, such as dust grains and gas particles. But it's not just about having the right ingredients. The conditions also need to be perfect for planets to form. Just like baking, the formation of planets is a complex process that depends on precise conditions. The temperature in the accretion disk needs to be just right, not too hot and not too cold. This balance is crucial because it affects how particles within the disk interact with each other. If it's too hot, the dust and gas will be blown away by the black hole's intense radiation. This intense heat can prevent the particles from coming together, dispersing them into space. But if it's too cold, the particles won't have enough energy to clump together and form larger objects. The cold environment makes it difficult for particles to move and interact, hindering the formation process. Density also plays a crucial role. The density of the accretion disk determines how often particles collide with each other. The accretion disk needs to be dense enough for particles to collide frequently. These collisions are essential because they allow particles to stick together and grow in size. So, just like baking a cake, the formation of planets is a delicate balance of temperature and density. Each factor must be just right to create the beautiful, complex worlds that populate our universe. The next time you look up at the night sky, remember the intricate dance of particles and forces that brought those distant planets into existence. It's a reminder of the incredible processes that shape our universe, from the smallest particles to the largest celestial bodies. Understanding these processes helps us appreciate the beauty and complexity of the cosmos. And who knows, maybe one day we'll discover new planets forming in distant galaxies, continuing the cycle of creation that has been going on for billions of years. As dust and gas particles move around in the accretion disk, they constantly bump into each other. These collisions cause the particles to stick together, like tiny pieces of cosmic Velcro. Over time, these clumps grow larger and larger, forming planetesimals, which are like baby planets. Gravity then takes over, pulling in even more material and helping these planetesimals grow into full-fledged planets. Imagine a planet orbiting a black hole. It's a delicate dance, a cosmic balancing act. The planet needs to be far enough away from the black hole to avoid being pulled in by its immense gravity, but it also needs to be close enough to be within the accretion disk where it can continue to gather material and grow. Finding that sweet spot, that Goldilocks zone where conditions are just right for planets to exist, is crucial. Too close and the planet gets ripped apart, too far and it drifts away, lost in the vastness of space. Section 6. Essential Ingredients. Conditions for planets. Not all black holes are created equal. Only the biggest and baddest ones, known as supermassive black holes, are thought to be capable of hosting planets. These cosmic giants have massive accretion disks, providing ample material and the right conditions for planet formation. The accretion disk itself needs to be stable and long-lived. Question that sparks the imagination. The very idea of life existing in such an extreme environment challenges our understanding of biology and the resilience of life itself. However, life on a planet would face some serious challenges. The surface of these planets would be unlike anything we have ever seen, with conditions that are both fascinating and terrifying. First, there's the intense radiation from the black hole. This radiation is not just a minor inconvenience, it is a formidable barrier that any potential life form would need to overcome. This radiation could be deadly to any life forms we know of. It would require life to develop extraordinary adaptations, perhaps even mechanisms we can't currently imagine, to survive such an onslaught. Second, the environment in the accretion disk is incredibly harsh. The accretion disk is a chaotic region filled with swirling gas and dust where temperatures can soar to unimaginable heights. The temperatures are extreme, and the gravitational forces are immense. These forces would stretch and compress any object, creating a hostile environment that seems almost impossible for life to endure. While the possibility of life on planets is uncertain, it's a tantalizing thought. Scientists and dreamers alike ponder the potential for life to adapt in ways we have yet to discover. It reminds us that the universe is full of surprises, and that life might find a way to exist in even the most unexpected places. From the deepest oceans on Earth to the most arid deserts, life has shown an incredible ability to thrive in extreme conditions. Could the same be true for planets? Only time and further exploration will tell. The search for life in the universe is far from over, and each discovery brings us one step closer to understanding the vast possibilities that lie beyond our own planet. For a long time we believed that planets could only exist around stars like our sun. But Blanets suggests that planetary systems might be far more diverse and exotic than we ever imagined. The search for planets is still in its infancy, but it holds immense potential. If we find them, it would revolutionize our understanding of planetary formation and the possibilities for life in the universe. Vast and mysterious place, full of wonder and endless possibilities. Planets are just one example of the many strange and awe-inspiring objects that might be out there waiting to be discovered. As we continue to explore the cosmos, we can be sure to find even more surprises that will challenge our understanding of the universe and our place within it.